Properties of rhombi, rectangles, and squares. If we go back to our tree diagram and review a couple concepts here, we have quadrilaterals which have 4 sides to them. If we look at our quadrilaterals that have 2 sets of parallel sides, we get into parallelograms, which have the characteristics of having 2 sets of parallel sides. Opposite sides being congruent, there are 2 sets of those. 2 sets of opposite angles that are congruent. We got 4 different sets of consecutive interior angles that are supplementary, or same side interior angles that are supplementary. We have diagonals that bisect each other. And then the 6th characteristic we talked about with parallelograms is when you're trying to prove that a quadrilateral is a parallelogram. You can prove that a quadrilateral is a parallelogram just by looking at one set of sides and knowing that those 2 sides are both parallel and congruent to each other. Now there are subcategories to parallelograms, just like there was subcategories of quadrilaterals which got us to the parallelograms. When we look at those subcategories of parallelograms, we'll see that there are 2 of them. One of them is the rhombus, and one of them is the rectangle. The rhombus is a subcategory of parallelograms because it has all the equilateral parallelograms, and a rectangle is all the equal angular parallelograms. So in the realm of, or in the category of rhombus, we have a rhombus being that it has 4 congruent sides, and when that happens, we end up having diagonals that are perpendicular to each other, which make right angles, and diagonals that bisect the opposite angles. In the rectangle realm, or rectangle subcategory, you have a parallelogram that is equal angular, which means you have 4 congruent angles, which makes them all right angles or perpendicular sides, and you have diagonals that are congruent. To get a square, what you have to do is you have to have a combination of the rhombus subcategory and the rectangle subcategory, which makes the squares the most complex parallelogram that we have, because the square has not just the characteristics of the square itself, but it also has the characteristics of a rectangle, the characteristics of a rhombus, and the characteristics of a parallelogram. A rhombus has the 3 characteristics that are specific to a rhombus, plus the 6 that are specific to a parallelogram. Rectangles have the 2 that they have for just rectangles, and the 6 for the parallelogram. So what you're looking at is rectangles have 8 characteristics, the 2 here plus the 6 parallelograms. A rhombus has 9 characteristics, the 3 here for a rhombus and the 6 for the parallelogram. And a square has 11 characteristics, the 2 for the rectangle, the 3 for the rhombus, and the 6 for the parallelogram. So there's different relationships between these quadrilaterals. Every subgroup is always a part of the group that's connected above it. So parallelograms are always quadrilaterals, but are sometimes rhombus, rectangles, or squares. So if you start low on the tree diagram and you work your way up, squares are always a rectangle, rectangles are always parallelograms. But as you work your way down, it is a sometimes. Parallelograms are sometimes rectangles, and rectangles are sometimes squares. Rhombuses are always parallelograms and quadrilaterals. Rhombus is always a parallelogram, and a parallelogram is always a quadrilateral. But a rhombus can never be a rectangle. But a rhombus is only sometimes a rectangle. The only time it's a rectangle is when it is a square. Rectangles are always parallelograms and quadrilaterals. So a rectangle is always a parallelogram and always a quadrilateral, because a rectangle is below the parallelogram. Rectangles on our tree diagram. And a rectangle is a subcategory of parallelograms, which is a subcategory of quadrilaterals. Relationships between quadrilaterals. Let's see. Every subgroup is always a part of the group connected above it. Squares are always rhombuses, rectangles, parallelograms, and quadrilaterals. So just taking a look here, here's a sample or a drawing of our first characteristic of a rhombus. You can see here you got your four congruent sides. Here you can see our second characteristic of a rhombus, where you got your diagonals that are perpendicular to each other. So you have one right angle in here, which means you have four right angles, meaning you have four right triangles. That also opens the door for using Pythagorean theorem to help find different lengths within each right triangle. And the third category of a rhombus, where you have the diagonals that bisect opposite angles. So in a rhombus, when you draw on a diagonal like BD, that means you got four congruent angles. This angle here, 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 and here. If you draw on diagonal AC this way, you have four congruent angles, these two angles here, and those two angles here. So you got two sets of four congruent angles when you draw on both diagonals. Here's your rectangle. Rectangle is equal angular, which means you got four right angles. And the diagonals are congruent to each other. This is important because if the diagonals are congruent to each other and they bisect each other, that creates four congruent segments. Each half of both diagonals are going to be congruent to each other, which makes them isosceles triangles. So you got two congruent isosceles triangles. You got this one on the left with the one on the right, and then you have the one on the top with the one on the bottom. Now keep in mind, when you're talking isosceles triangles, that means you also have base angles that are congruent to each other. There are some relationships between the quadrilaterals. This means that if you are given a rhombus, that means you can use not only the theorems for a rhombus, but also the theorems for a parallelogram, since a rhombus is always a parallelogram. But you cannot use the theorems from a rectangle. Rectangles can use the theorems from rectangles and parallelograms, but not the theorems from a rhombus. Squares can use the theorems from rectangles, rhombi, and parallelograms. So which of these types of quadrilaterals are equilateral? That would be the rhombus and the square. Which ones are equilateral and equiangular? The only one there is the square. Which one has diagonals that are perpendicular? That would be a rhombus and a square, because a rhombus has the perpendicular diagonals, and a square is also a rhombus. And which one has opposite sides that are congruent? That would be all four of them, because if a parallelogram has the opposite sides congruent, that has a trickle effect down to the rectangles, rhombi, and squares, because a rectangle, rhombus, and a square are each subcategory of a parallelogram, which means they are all in their own right parallelograms. Diagonals bisect each other. That would be all of them again, because the diagonals bisecting each other is a parallelogram rule, and rectangles, rhombi, and squares are all parallelograms. The diagonals bisect opposite angles. That one is strictly for a rhombus, but because a square is also a rhombus, we can say it works for both rhombi and squares. To tell whether 4 points create a rectangle, rhombus, or a square, the first thing I would suggest doing is finding your slopes of each side and then finding your side lengths. So here we got P at 3, 1, Q is at 3, -3, R is at -2, -3, and S is at -2, 1. We find our slopes here. The slope of PQ is 4 over 0, which is undefined. The slope of RQ is 0 over 5, which is the slope of 0. The slope of SR is 4 over 0, which is undefined. And the slope of SP is 0 over 5, which is 0. Now, you can see that opposite sides have the same slope. You got a 0 here and a 0 here. You You got undefined for PQ and undefined for SR. That tells you that it has to be a parallelogram. The next thing to take a close look at is it looks like you got right angles here. To verify that, you're looking for opposite reciprocal slopes. One of the hidden difficult opposite reciprocal slopes to know that you just have to memorize is that undefined and 0 are opposite reciprocals. So you can see here from undefined to 0 you got opposite reciprocals, which means point Q is a right angle, and from 0 to undefined is opposite reciprocal again. So that would make R a right angle, and you see that pattern all the way around here. So you got 4 right angles. That tells you that you have a rectangle. Now we got to look at our lengths. PQ is 4, QR is 5, RS is 4, and SP is 5. That tells us that it's not equilateral. So if you go down your tree diagram, you have the idea that the opposite sides have the same slopes, which means it's a parallelogram. Then we checked for the opposite reciprocal slopes, which told us it is a rectangle. Going down here with our lengths, we got 4, 5, 4, and 5, which tells us it's not equilateral, which means it's not a rhombus. So if we got a rectangle that's not a rhombus, that means it has to be a rectangle. Some quick reminders about graphs. If the slopes are equal, that means your lines are parallel. If the slopes are opposite reciprocals, that means that the lines are perpendicular, creating right angles. And if the distances are equal, that means the lines are congruent.